Now in this lecture, we are going to learn what is a graph. A graph is a nonlinear data structure consisting of nodes and edges. The nodes are sometimes also referred as vertices, and the edges are lines or arcs that connect any two nodes in the graph. More formally, a graph can be defined like this. A graph consists of a finite set of vertices or nodes and set of edges which connect a pair of nodes. Now let's see what we mean by vertices and edges. So here you can see the typical representation of graph. So in this graph, the circular objects over here are called nodes, and the lines that are connecting them are called edges. So with this picture, hopefully you have understood the definition of graph data structure. Now let's see why we need a graph data structure. Graphs are used to solve many real-life problems. Graphs are used to represent networks. The networks may include paths in a city, or telephone network, or circuit networks. Graphs are also used in social networks like LinkedIn, Facebook, and others. For example, in Facebook, each person is represented with vertex or node, and each node is a structure and contains information like person ID, name, gender, or location. And by using the vertices, we are connecting the nodes together. In Facebook, we are connecting the people together. Now let's say we are given a problem called shortest path between cities. So here we are given a map of Europe to find the shortest path between cities that are mentioned over here. Now these cities are connected using the paths over here. So these black lines over here shows the paths between the cities. So here it means that from London to Moscow we have direct flight, and from Moscow to Baku we have another flight over here. So with these lines we can see that from London we have flights to different cities in the Europe. So let's say we want to find a shortest path from London to Baku over here. Now in this case, from London to Baku, the first path is like this. We can come to Istanbul, then we can come to Baku, or we can come from London to Kiev, then we can come to Baku, or we can fly to Moscow, and from Moscow then we can come to Baku. So as you can see, we have different paths from London to Baku. So the question is, how can we find the shortest path to Baku? So in this case, we need a data structure which can handle this. If you look at the data structures we have learned till now, we can easily see that the only option is a tree data structure, because tree data structure has nodes and these nodes are connected with path. So here we can use the nodes as a city name, and the flights that we have over here with the black lines, we can denote them as a line that connects the nodes. Now the problem over here in case of tree data structure is that we don't have cycle. But here in this map, you can easily see that we have a cycle over here. For example, from London, I can come to Istanbul, and from Istanbul, I can come to Baku, and from Baku, I can go to Moscow, and from Moscow, I can directly go to London. So as you can see over here, we have a circle over here. But in case of tree data structure, we cannot handle this case. So in case of tree data structure, we don't have circle in our data structure. Now the only option is graph data structure. So by using graph data structure, we can express cities as nodes, and the path between these cities over here can be expressed as an edge in the graph over here. Now with this, we can easily solve the problem of shortest path. So as I said, in the typical graph we have vertices and edges, so we can represent cities as vertices and connection between them as edges. Now the problem is, after representing these cities and the path between them in a graph data structure, how can we solve the shortest path problem? So we will discuss it in our upcoming lectures. For now, you just need to know that in such cases, we are using graph data structure. So only graph data structure is suitable for solving this problem. So hopefully you have understood what's a graph data structure and why we need it. Now in the next lecture, let's see graph terminologies which are very useful when dealing with graphs. So in the interview also, whenever an interviewer asks something related about graphs, so without knowing the graph terminology, you will have difficulties to understand the question. So that's why graph terminologies is very crucial in all cases, when you are dealing with graphs or when you are participating in interview process. Now, in the next lecture, we are going to discuss about graph terminologies. So see you in the next lecture.